All right, welcome to the third Fusion training, specifically for Enable members. So today we're going to go through a couple of things having to do with parametric workflow. So we're going to look at some kind of basic modeling strategies, things that are totally effective, and then look at some kind of slightly cleaner, more elegant ways of doing things that are more conducive to driving geometry parametrically. Let's see, then we're going to go through some other tools, specifically importing images, scaling those to size, and then building geometry off of those images so that you can kind of make custom kind of body interfacing parts and use a template hand for building new fingers. Again, we'll kind of apply some of the parametric workflow stuff that we went over in the first part, and then finally we'll go over importing some 3D geometry in the form of OBJ files and take that into a more editable analytic surface that we can start to play with in a parametric way. One other thing I'll mention, so today is the 27th of August. In just about a week, a little under a week, a big new Fusion release is going to come out. So a lot of things on the layout of Fusion are going to change. Most of those are just going to be dashboard related. So there will be some additional functionalities, things like scripting. There's a new Fusion API for writing geometry with JavaScript. A lot of really exciting stuff. So I'll go through and do some tutorials in another couple of weeks covering some of those new functionalities. But just a heads up, some of the layout is going to change, but all of the kind of core functionality of the modeling, things like that, will all be the same. So with that, let's go ahead and dive into the screen share. And we'll start with kind of going through some modeling strategy here. So this is something that I went over briefly in a previous Hangout, but there's slight technical difficulty. We didn't capture all the information, so this time we'll actually get all of the details. So we'll start with here. We just have a kind of a regular proximal phalange, very similar to the one in the Cyborg Beast. So we've got two holes for Chicago screws. We've got a hard stop up here. We have some kind of bosses on the side here to flesh out the finger, and then we've got these cable channels running right down the central axis of the finger. And so if we look at how this was modeled, we can just go down to this little timeline here and click the play button. And you can see that we kind of made a central feature, then kind of bossed out on either side, ran the cable channels through, then came in out of that hard stop, and then kind of rounded everything out to make it a little more ergonomic. So you can see in terms of number of sketches, so number of times we went from kind of 2D geometry to 3D geometry. There were 8 sketches, and then we've got something around 20 kind of features down here that we put together to make this geometry. And so making the same geometry, flipped over to a slightly the same geometry, just slightly modeled in a slightly different way. So this is if I were modeling to share with people, this is kind of how I would go about it. So this has been designed to be more shareable and to also be parametric. So instead of being kind of a custom one-off, it's designed to be editable by other people and to be adapted to their needs. So I put it together in a slightly more elegant, efficient way. You can see instead of 8 sketches, I just used 5. Additionally, I labeled those sketches so that other people can see what information is contained in that sketch when they're coming back. If they'd like to make some additional modifications, they can come back, look at the sketches, and pull that information out. Additionally, I used maybe 30% fewer kind of modeling moves down here. So if we flip back to the first one that I did, so you can see the 8 sketches, and then about 20 moves down here, 20 features. Down here, we've probably got about like 15, 16 features. So again, a slightly more efficient modeling workflow. And so to kind of reveal some of the tricks, kind of shortcuts here, if we go through and play this out, you can see that there's that central feature again, but actually it's thinner than before. And you can see that the kind of big trick here was modeling half of it, and then we used a mirror feature to double and just mirror over, use the fact that this object has symmetry to save ourselves some time modeling the second half of this. And then again, we put all the fillets and chamfers on at the very end so that they don't disturb any of our modeling and parametric features. So the thing that's kind of extra special and important about this geometry is if you go down to Modify on the toolbar, down at the very bottom to the Change Parameters button, go ahead and pin that up to the toolbar, and go ahead and click the Sigma, the Change Parameters button, and it brings up this little window. Not terribly exciting, just looks like a spreadsheet, but it's got some pretty neat features. For instance, we can come in and change the length of the proximal phalange here, so we can immediately add or subtract 5 millimeters, really dial in that fit if we'd like, just by editing this parameter here, phalange length. Additionally, if you want to maybe add a little more height, we can change the height of the phalanges using this phalange height parameter. Again, each of these parameters has a little comment section where I've laid out just a very brief description of what that parameter does, how it drives the geometry. And we can also kind of one of the things that I'm kind of most excited about, kind of making some of these designs more parametric, is the ability to embed clearances. So a lot of different 3D printers can achieve different tolerances when they're depositing material, and this kind of comes into play both when we're sharing one design at one scale and printing it on multiple machines. And it also comes into play when we're applying a linear scale to an STL, which is something we've been doing for a long time in Enable. The funny thing is, when we're scaling linearly, we're changing the size of the holes that the pins and Chicago screws fit into, and clearances are a kind of an absolute value. If you have a clearance of 0.5 millimeters at one scale, and then you double the scale, your clearance is suddenly going to be a full millimeter. So you're going to have much more kind of play in the system. Likewise, if you were to have the scale go to 50%, you'd suddenly have a 1/4 millimeter tolerance, and you might not actually be able to kind of achieve smooth motion at that point. So here we can now dial in the tolerance, and you can see it's a subtle motion. I'll zoom in and kind of repeat here. But it adjusts the kind of radial clearance for both of the knuckle joints here. So I'll use a really big clearance here, and you can see it kind of pull in that central, those central boss features to keep them out of the way of the knuckles. Additionally, we can adjust the width here, so we can make a very wide finger, or bring that in to make it a more narrow finger. If we go too fine, we'll start to run into problems. You can see that I got a little error there. Close it. If you do get an error, just exit and undo any changes to parameters, and you should be in good shape. Finally, again, kind of getting into the different tolerances the different machines are able to pull off. Some machines might have trouble kind of clearly resolving these cable channels, and so if you want to bump up the diameter of those cable channels, we can come in and adjust that here. So this is a pretty powerful kind of tool set, especially when it comes to sharing geometry. So instead of having to kind of start from scratch each time, we can just share these kind of precompiled pieces of geometry that have this really nice kind of this really nice set of driving parameters. So it should make it much easier to size things for different individuals. And so with that, unless there are any questions on these kind of tips and tricks for parametric workflows, I think we can move on to image importing and working from image data. So any questions on this parametric stuff?
So far, our Q&A is clear.
All right, great. So moving right along. So one of the other really kind of powerful workflows that I've used a lot in Fusion is the ability to take in an image and paste it down on a plane in Fusion. So I'll just select this XY plane, again RGB XYZ for just for orienting. So I'll select the XY plane here, and then I'll go to select image. I'll go over to my documents, over to enable, Fusion tutorial, and photo 1. So you can see I've pulled in an image here. I'm going to rotate that around just for kind of comfort's sake, making my fingers point up here. I'm going to drop the opacity down just so I can see when I'm drawing lines on one side of the image and on the other, and then click OK. And then I'm going to just click on the view cube up here to transition to the top view. So looking down, you can see I've got an object for scale here, just a regular clipper card. Then I've got my kind of template hand, and then I've got my target hand. So I've just photoshopped off my fingers and thumb here. You can also see over here on the left in the kind of browser bar, we have this new folder called Canvases, and you can see photo 1 has showed up under here. So if you right-click on that and then click on Calibrate, it just brings up a very simple tool, a pair of crosshairs. Zoom into your calibration object, and here I've got this nice horizontal line across here, and I know from measuring earlier that this clipper card is exactly 54 millimeters across, and this is a pretty standard dimension for all kind of credit card size things. Definitely encourage the use of cards that don't have any identification or sensitive information on. So credit cards, maybe not the best object for scale. If you live in the Bay Area, the clipper card is pretty nice. Zipcar cards, things like that, all work great. Also, you know, coins. Coins are another good object for scale. So now the entire image has been scaled up so that if I come in and just make a line here, so I'm just going to select the same plane. It's going to make a line right across that clipper card. And you can see if I come back to, it's going to pin my dimension tool, come in and measure that, we're almost at exactly 54 meters. So we've got a pretty negligible kind of measurement error there. So the next step is let's go ahead and just make some measurements here. So I'm just going to kind of rough out, kind of knuckle to knuckle, 3 measurements, getting the length of these kind of 3 phalanges here. I'm just going to come back, measure this guy, and measure this last one here. So going from distal to proximal phalanges. Bring up my parameters here. You can see that I've got sketch 6. So at this point, it's obvious that I've been doing things in this document before. Usually, it starts with sketch 1, and then dimension 1, dimension 2, dimension 3. But it ties the dimensions in a sketch linearly to that sketch. So dimension 17 is this top one here. So I'm going to call that IDP, index distal phalange. The 18, you can check the expression value against what's displayed on the dimension here. This IMP, index middle phalange. And then down here, the last one is the index proximal phalange, so IPP. Whoops.
Andreas?
Yes.
We have a question. The question is from Kyle Moore.
Okay.
I don't know if you've already addressed this, but can you show those parameters, how those parameters are entered during modeling?
Yes, I will be doing that in just a moment.
Okay.
Great. So because I was kind of doing a dry run of this demo before, it's giving me a hard time because I had originally called that parameter capital IPP. So I'm just going to settle for lowercase IPP and actually just for homogenization, bring these all down to lowercase. You can call these whatever you'd like, as long as it's kind of one sequence. So you can't use spaces, but basically the same rules apply as for labeling variables in code. So you can go ahead and close out of the parameters menu, stop the sketch, and we're ready now to start building a phalange over here. So the kind of first order of business is to build the plane on which we'll be working. So I'm going to enter the sketch mode again, select the plane of the image, and I'm just going to kind of more or less try to mirror, just with a single line, the axis of the index finger on the target, or on the template hand, and mirror that over onto the target hand. And I'm just going to go ahead and right-click on that and make it a construction line, just for kind of bookkeeping sake. I'm going to stop the sketch, come over to the construct menu, and click on plane at angle. What that does is it lets you select an edge or a line and lets you lay out a plane that intersects that line, and then you can set the angle at which it intersects. So I'm just going to set that to 90 degrees using the kind of manual rollover tool that snaps it at 90. To create a plane that's perpendicular to the image plane, but parallel to the axis of the index finger here. Then I'm going to select that plane and re-enter sketch. So I'm going to repopulate my toolbar. I started with the kind of very basic toolbar that when you open Fusion for the first time, loads this very basic set of tools. Some tools I use a lot when I'm modeling, I use the 2-point rectangle a lot, so I'm going to pin that to the toolbar. I use a center diameter circle, I'll pin that up. I use the trim, the offset, and the project as well. So we're going to start by using the project, and we're just going to project the line in here, and I'll show you why we're doing that. Usually you can snap to geometry when you're editing a sketch, and you can see that there's no kind of snapping action going on when I mouse over the line, and that's because it's in a different sketch. So if we want to take 2D geometry or a face or an edge from some 3D geometry, if we want to pull that from another sketch or from a solid body into the sketch that we're working on, we use the project tool. Just click on that, and now you can see that when I mouse over, it highlights that that line. And when I click, you can now see that there's a thin purple line. And when I mouse over now, it highlights that line. So, so next, I'm going to try to find where to kind of anchor the knuckle here, and I'm just going to lay a point there. This looks about where I'd want to put my proximal knuckle, and I'm just going to fix that point. Fixing the point just makes sure that I can't slide it around as I start to change other bits of geometry. So I'll show you, if I don't fix that point, I can slide it up and down this line, which when you're trying to, if you're trying to kind of model things with reference to the kind of underlying image geometry, you want to kind of keep things fixed in place so that those kind of references hold. So next, now that I've fixed that point, I'm going to create a couple of circles and connect them pretty haphazardly with a couple of lines here. So you can see we've got 2 circles of different sizes here with lines that are definitely not parallel or perpendicular to any of our kind of reference planes here. So one of the kind of final tools that's really important in 2D geometry construction is constraints. So I'm going to go ahead and pin that to the toolbar here. Constraints let you precisely define relationships between pieces of 2D geometry. So there are a variety of different options here. Coincident, collinear, concentric, midpoint, fix, unfix, parallel, perpendicular, horizontal. You can kind of run through the list there. They're very important for establishing relationships that are less dimensional and more relational. So for instance, I want these two circles, which I'm going to use to compose the proximal and distal knuckle of the proximal phalange here. I want those to be the same size, so I'm going to move down to equal here and just click on the two circles, and you'll see now they are the same size. Additionally, to make sure that these two lines are parallel and are intersecting these circles at the same point, I'm going to go over here and click on tangent, click on the line, click on the circle, click on the line, click on the circle, and you can see this little glyph popped up here that matches the glyph next to the tangent here. So that's just indicating that we've made this line and the circle tangent to each other. So this is about all the kind of constraint that I want right now. I'm actually going to go ahead and add a horizontal constraint here. Actually, it looks like I'm constrained enough, so it's not letting me do that. It will try to kind of keep you from painting yourself into a corner. It's very possible to build geometry, or kind of impossible geometry, or almost impossible geometry, and kind of, really put yourself in a sticky situation if you're not careful. So definitely kind of constrain with a light hand when in doubt. Next, what I'm going to do is I'm just going to come and add a little bit more geometry. I want two circles here, and you can see a little glyph popped up. This is the concentric glyph, just indicating that my circle here is concentric with my circle here. Just making sure that they share the same center point. So now I've got my kind of base geometry laid out. This is the same base geometry from laying out our proximal phalange earlier. I'm going to come back here and bring up my parameters. So there are a couple of kind of relevant parameters that we're going to want to put in here. So the first one is the length of the index proximal phalange. So I'm going to call that IPP length. It's going to be in millimeters, and we're going to take the value that we measured and just put it in here. So again, you can see back in sketch 6, the previous sketch, we measured the proximal, middle, and distal phalange. So I'm just going to take that value, that parameter, and just pass it in here. And so you can see it's updated that value already and pulled that from our template geometry. So I'm just going to put a comment here, length of the index proximal phalange. We're also going to need the diameter of the pinholes. So I'm going to do pin diameter. We'll maybe start with 6 millimeter pins. A little comment on there. With the pinholes, having pin clearance is going to be important. So I'm just going to make a pin clearance. We'll start with 0.5 millimeters, something pretty generous. So pinhole clearance. And then finally, we're probably going to want phalange height, just the height of the finger here. And we can just make up a value for now, and then height of the phalange for our comment. So now we have a pretty good understanding of what values are involved in kind of building this geometry out. So I'm going to go ahead and close that, come back, and start setting some of these values. So you can just pass the parameters right into the dimension window here, and it will update that to reflect the geometry that you passed in. And you can come back and change that value. You can see it has everything in its kind of recent memory listed here if you click on the little drop-down menu. If you want to change that, you can come back. I'm just going to the IPP length. I'm going to then take this, oops, set the height of the phalange to phalange height, and you can see if it doesn't recognize the parameter, it'll turn red. When it does recognize the parameter, it'll turn black and let you pass that in. Next, I'm going to come in and actually, because I know that these two pinholes are going to be the same, I'm going to go ahead and make these two equal to each other, just to save myself a dimensioning step. Here, I'm actually going to pass in an expression. So I'm going to say pin diameter plus 2 times the pin clearance. So what I'm doing here is kind of sizing the hole for the pin and then adding the clearance value to both sides. And so that's giving me a hole with an ultimate size of 7 millimeters because we're passing a 6 millimeter pin through here with ½ a millimeter of clearance on either side to make sure that we have kind of good motion on there. And so you can see if we come back and check our parameters here, it's often good to kind of test drive your parameters a little bit while you are still in the sketch geometry, make sure that nothing's over constrained. So you can see when we adjust the parameters here, we get different values, or the geometry responds to the changes that we're making. So I think the pinholes probably look good where they are. Make a nice beefy pin there. 15, I might make that just a little bit thicker. Really, what you can do is actually on this plane that we built to just bring it up here, the plane that we're working on right now, that we're laying out this 2D geometry on, you can actually come in and add another image and calibrate that image and get a profile of the finger, and so pull that height value from there. We'll just kind of let that slide this time and just make up this value, kind of freehanding, guessing that these are basically round, kind of cylindrical fingers, about 16 millimeters wide. So we'll go ahead and stop the sketch. And now that it comes time to kind of bring this out into 3D, give some width to this, we know that we're going to need to define the width of the finger somehow. So I'll bring on my parameter menu again. I'm going to, we're going to go ahead and make these pretty square sausage fingers. So I'm going to add a parameter phalange width. I'm going to make that 16 millimeters and just call this width of the index. So now when I go to use the modify tool to take this 2D geometry here, and I'm just selecting the profiles, when I go to pull that out to 3D form, what I'm going to pass in is phalange width divided by 4. Whoops. Something happened there. Let's try that again. So I'm having to select the 6 different profiles because I left the line that I projected into this plane, this kind of construction line. I left that as a, actually go back and fix that. I left that as a regular line and not a construction line. So I'm going to go ahead and toggle that. Oops. I'm not going to break the link. I'm going to toggle that to construction geometry. So now you can see that there are 3 unified profiles instead of these bisected profiles. So I'm going to select those 3 unified profiles, and I'm going to set that again to phalange width divided by 4 because I'm going to be mirroring this. I ultimately want to add an additional boss to kind of expand the width of the finger, while creating space for the middle phalange to join, and creating space here for the this knuckle to plug into the palm. So I'm going to be creating that boss here. I'm going to set that width also to phalange width over 4, and then when I mirror this whole geometry over, I'll have my total phalange width equal to the target value of 16 millimeters. So now you can see we've got this phalange roughed out here. I'm going to start modeling on this face to make the that kind of width addition boss here. I'm going to just do 2 circles, both centered on the pin axes, the kind of knuckle axes. I'm going to go ahead and just add a construction line here, spanning across, and toggle that over to construction. I'm going to expand my sketches over here because it's getting a little messy. Make sure that those previous sketches are muted out just to kind of clean up the modeling environment a little bit. So now, go ahead.
Sorry to jump in. Quick question from Kyle Moore. Are parameters global? Are they usable across different files?
They are not. They are tied to the file that you're working on. We'll have to see if they've changed that in the coming updates. I'm not 100% sure. There might be some tricks you can play with that, but I believe that they are local to the design file that you're working on.
Okay, but they are saved with the file that you're working on?
They are saved with the file. So the kind of structure of the file, the timeline of the file, and the parameters are all saved together. And I should mention, actually, I'm going to export these demo files after this, zip them up into a little library that I'll post so that everybody can download and open these. It makes it, I realized it was a little tricky kind of inviting people to join the sandbox to get access to the files. It's a little kind of high barrier to access. So if I make the files available to download, it makes it much easier for folks to kind of tinker around with them. It also makes it harder for anything to happen to the source files. Although version control is very easy with Fusion, so you can just undo any changes that might befall your files. So back to this geometry here. Because just because we might be interested in this, I'm going to go ahead and make another parameter here, and I'm going to call it knuckle clearance, just to differentiate it in case we need to change these later. I need to do some experimentation, see if knuckle clearance and pin clearance actually need to be separate parameters. If they don't, we can just set them to each other without any trouble and kind of make the file a little more elegant that way. Otherwise, I'm just going to go ahead and set that to the same value, but just in case, actually, I'll make it a little larger. Just to kind of demonstrate the ability to kind of wrap in different clearance values for different parts of the geometry that might require different clearances. So the knuckle geometry. So what we're going to use this parameter for is setting the distance between this circle, these outside circles, and the inner knuckle circles. So I'll call that knuckle clearance. And I misspelled that. There we go. And again, I'm just going to go ahead and make these two circles equal to each other. Next, I'm just going to take a line, drop it from that intersection point down here to the bottom of the profile. Going to repeat that over here, making sure that perpendicular and those coincident glyphs pop up. Again, the coincident and tangent glyph pop up here. So now we've got that profile that we're going to extrude out for the that boss finger to kind of flesh out the side of the finger. So I'm just going to go ahead and pull that out. Click on the drop down, pull up that phalange width over 4. And so now we've got that half phalange ready. So next, let's go ahead and I'm going to go ahead and just mute the photo here, just clicking the little light bulb next to the photo 1 under the canvases, just to kind of make it a little easier to see. We've already pulled the kind of really salient geometry from the target or the template hands, and can start to just work on building out the geometry now. So next, I'm going to cut the cable holes through. So I'm going to again come to my construct drop down here. We need to somehow orient a plane and put some 2D features on that plane, put some circles on that plane to carve out those channels. So I'm going to come down here and select tangent plane. And you can see that it's kind of drawn a plane at a pretty arbitrary tangent here. You can see that it's not actually kind of perpendicular to anything we're interested in. So I'm just going to select a face up here, which it will now reference off of, and I'm just going to drag this over to, let's see, 10 degrees. Now, why it shows 10 degrees? Let me actually restart that and choose a better reference geometry. Let's make it parallel to this plane here. And so now we're parallel to that reference plane. This is just the deviation from that angle at which it started, which was an arbitrary angle. So this is kind of an arbitrary deviation. So we can just leave that as it is. And so now we've got a plane, a reference plane here, that we can work with, drop some geometry onto that. So the first step, let's go ahead and start sketching on that plane. You can see now we're kind of bisecting the phalange in progress on that plane. Let's go ahead and project this face onto the plane here, and then we're going to come in and add a couple of circles here and here for the cable channels. So now that we're ready to make the cable channels, we know that those are something that we're probably going to want to change in the future. So I'm going to go ahead and make a cable channel parameter here. I'll go ahead and set that to 2.5 millimeters. So it'll just be the diameter of the cable channels. Close out of that. Just set that to cable channel. Make these two equal to each other again. And now just going to kind of touch off these reference geometries here. I'm going to make that 2.5 millimeters down, and also going to make this guy 2.5 millimeters down. You'll notice that I centered these circles on this edge because this edge is going to be intersects the plane across which we're going to mirror this geometry. So we really only have to build half of the geometry out using these circles. So go ahead and exit the sketch, and you can see here that we can select easily the profile on the left side. But if we want to get the profile that's inside the body, it's not highlighting when we mouse over. So if you just mouse over where the profile should be, then click and hold, it'll bring up a little menu with everything that's possibly in the kind of underneath your mouse. So you can see it's picking up the back face, the front face, and then that profile in the middle that we're actually after. So we'll select that, and then we'll go ahead and do the same down here. Select that profile. Actually, we'll shift, make sure we get both of those. And you can see that we actually have to cut in two directions in order to kind of fully get those channels. So I'm just going to do two sides. Another arrow pops up, and I'll just go ahead and drag those out. In this case, a pretty arbitrary value. This is something that you can freehand. If you wanted to, we could be precise and call this. We will never need this to be more than the length of the, we'll make it 2 times the length just to be super sure. we'll also make that 2 times the length of this phalange. So now we're guaranteed, no matter what we do to the length of this, the distance that this cuts is always going to be twice the total length. So we're never going to run into trouble with actually getting these cutouts all the way through. So the final thing is we need a little bit of clearance here on the underside here to match what we've got here to kind of cut out the channel, like give it a little of kind of underside clearance. So back to the image here. Just going to go ahead and start sketching on this plane. Come back and project here and here just to kind of bring up some reference geometry to work with. I'm going to go ahead and just kind of draw a rectangle here and a rectangle here and set the distance. Whoops. Set this depth. Whoops, we are somehow a little bit out of parallel. Let me just clean that up, clean up the view. Just going to drop a rectangle here, drop a rectangle here. Interesting. I'll just drop a line down here, 90 degrees over, and bring that up. If you just tab over, you can control the angle at which you're incident. So I just tabbed over to make sure that we're coming in. Now you can see I'm constrained to 90 degrees. I'm just going to come up and click here. I'm going to come down. You can see I'm at 90 degrees. Come over. Again, it's not snapping to 90. Might be getting confused about some of the geometry, so I'm just going to enforce 90 and come up. I'm just going to go ahead and drag because I missed that first time. Now we've got just these two rectangles, and actually I realize I don't even need to do that. I can just come in and drop a line straight down here and straight down here. I'm going to kind of, what we're doing here is just creating those that kind of cut out on the bottom. So I'm going to set this distance to just the IPP length by 4, and do the same over here just to kind of give it a something that will scale with the length of the finger. Sorry, and that's IPP length divided by 4. Great. So I'm going to go ahead and exit out of the sketch. And so now I'm going to drag those profiles back to cut. Actually, sorry. A little short-sighted. I actually do need to include some geometry up here. So I'm actually going to pick up the midpoint here, come down here, pick up the midpoint here, just extend outwards, just creating some geometry to work with. I'm just going to set that, force that to 0, intersect over here. So I do want to be able to cut out the whole of this channel and not leave this kind of little fragment of the circle channel there. So I've now got a total of 2, 3. Let's see. It looks like there's still something a little bit off down here. I'm just going to go ahead and delete that, delete this, and yeah, sorry this is a little bit messy, folks. It's been a little bit since I've modeled this particular geometry, so I'm going to go ahead and set that again to length, IPP length divided by 4. And I misreferenced that relative to my other one. I'm just going to match that up relative to that point. IPP length divided by 4. And so now we should have 1, 2, 3, and 4 profiles, and I'm just going to take those back the width of the cable channel over 2, just to get a nice clean cutout, giving that kind of underside clearance for the cables. Finally, a final piece of business here is we need to add that hard stop. So I'm just going to come up, do a vertical here, going to come and grab my arc tool, grab a center point arc. So I'm going to click on the center, the start of the arc, the end of the arc, and I'm just going to dimension that out. We might want to adjust this parameter in the future, so I'm going to go ahead and make a hard stop height parameter here. Just going to call that 3 millimeters, which is basically what we have here. And just add a quick comment here. Close that out. Hard stop height. So now that's something that we can drive parametrically at a later time if we'd like. Go ahead and modify this. Make this. You can see that it's negative just relative to the what it assumed was the front and the back of the plane. So we're just going to set that to negative phalange width divided by 4, just to match it to the dimension we have here and make sure that it scales properly with respect to the rest of the phalange here. And so now we're ready to mirror this over. So I'm going to expand out bodies. Here's the body that we've been making. It's called it body 4 because there were a couple of other pieces of geometry in this file before I started. Under Create, we're going to go down and select Mirror, which is something I use a lot, so I'm going to go ahead and pin that to the toolbar. I'm going to select Mirror. I'm going to click on the body. I'm going to come over under Mirror Plane, and I select that middle plane there. And it didn't like that, so I'm going to go ahead and just create an offset plane, offsetting at a distance of 0. Going to, again, select Mirror. I'm going to select that body and that mirror plane. Interesting. Can't tell you exactly why it's having a bit of trouble with that. It might be due to some of the kind of messier modeling I was doing earlier. If we toggle over to how this was done earlier, when we get to the mirror point, when we have half of our phalange here, so you can see we're at the same point. We've got the hard stop. We've applied the kind of underside cutouts to give the cables the flexor cable clearance. Have all of the other geometry that we want. We can then come click Mirror, select our body, and then select the face that we want to mirror off of. And so you can see in this file, it's not having any trouble with that. Click OK. And so now we've mirrored and joined those two faces to create the complete geometry. So the last remaining thing, which we can just walk through on this side, if you drop down and modify and just pin the fillet and chamfer tool, these are really useful tools for just cleaning up geometry. Order of operations can be a little important, especially when we're dealing with these kind of diminishing features where things narrow down to a very fine edge. Sometimes order of operations is important, sometimes it's not. It's a little hard to kind of develop an intuition for that. This is also something that you can generally freehand because it's more of an aesthetic and ergonomic operation, so you don't necessarily have to drive it with parameters, but you could if you'd like. So I'm going to go ahead and just select these profiles here, and it looks like there's an interesting fault due to unclear due to what. It might just be how it's referencing some of the internal geometry from the mirror. So we can just come back, try a different scheme, and again you can just use these little arrows to kind of try different values by feel. And again, so the fillet applies a round to that edge. The chamfer applies a square edge. So you can see if we use the chamfer, it just applies kind of a hard cutoff. So we can repeat that over here, dragging these in. I think I dragged those in a 1.5 millimeters on the other side, and then we can come back and apply our. Looks like I missed an edge here. I'll just come back and capture that really quick. And so then we can drag in chamfer and clean the geometry up, make it a little more body friendly, take off some of the sharp edges, things like that. So so again, we've got that kind of cleaned up, more body friendly geometry now. So any questions on the kind of the workflow of working with the image, pulling dimensions off of the image and working with the parameters? I should mention also you can save the kind of common used parameters by favoriting them, and they'll show up just at the top of the menu. So it saves you a little bit of time scrolling down, makes it a little more user-friendly to other people who might be kind of perusing your design files. So any questions on any of this workflow?
We're clear on the Q&A right now.
All right, great. So the final thing I wanted to cover tonight is importing an OBJ file, which is kind of a close cousin to the STL file. But instead of being a tessellated triangular mesh, as STL is, the OBJ is actually a quad mesh, which turns out to be important because Fusion has a lot of mesh modeling capabilities, so things for doing more kind of sculptural, soft, organic forms. And it's, while Fusion can't import an STL and then edit it, it can import an OBJ and give you kind of analytic control over that surface, let you edit it, apply various symmetries, and also apply parametric features to that. So to import an OBJ file, go to the Assemble dropdown, and at the very bottom is the Insert button. So click that. It's just going to open up and kind of comb through, see what you have stored in your kind of Fusion profile. So it brings up all of the projects that you're a member of here. I've parked an OBJ file over in this test project. The OBJ file happens to be called Airboat. It's a very simple little prop-driven kind of Everglades style boat that I just pulled off the web. We have actually surprisingly few OBJ source files within Enable, but for those who are modeling in kind of mesh tools like Blender, it's just a matter of exporting to OBJ, and you'll get this quad mesh. So if we actually zoom in here, you can see the quads on the different pieces of geometry. You can see that instead of being composed of triangles, it's actually composed of these rectangles. So you can also see that whoever modeled this, again, just kind of a random model from the internet, it's actually a series of discrete bodies. So I'm just going to go through and mute these out so that we're just working with one piece of geometry, this seat here. So nothing crazy, just a somewhat kind of crudely modeled. You can see it's definitely recognizably a seat. I'm going to switch over to mesh mode by clicking on this create form, and you can see we're now in the sculpt environment. So now we have a bunch of pretty powerful mesh manipulation tools. Now that we're in sculpt mode, if you right-click under bodies on the body that we've left highlighted and click Convert, it selects the body and gives you this little conversion menu. Just click OK, and it's going to convert this into an analytic surface. So you can see we've got the same geometry now, but when I mouse over, it actually highlights individual edges and faces. So if I wanted to modify this seat, maybe provide like some head support, I could select a couple of faces here, then click Modify, and it kind of gives me this little tool that lets me rotate the faces, move, and scale them. I'm just going to go ahead and drag this up a little bit, and then maybe drag that forward, just demonstrating that you can change the shape of this mesh. Next, I'll go ahead and grab these middle pieces here and just drag those back a little bit, just to give it a kind of an more oddball shape. However, something to be aware of, especially when working with thin surfaces, is you can see that there's something kind of funny going on here. What we've done is pulled one portion of the mesh through the other, which will not result in a kind of, well, no, Fusion won't let you convert that to a solid form, which is what we're going to do next. So I'm just going to go ahead and leave it there, and just click OK. So next, now we've got this this kind of editable form, we could do some more mesh manipulations, but I'd like to add some parametric features. So I'm going to click Finish Form. It's going to think for a minute, and then it's converted that form into a solid body model. So we now have a solid that we can work with. We click down under Bodies. We now have a solid form, which is pretty exciting. So if I just bring up my origin again, I'm going to go ahead and just drop a feature onto this plane, do some sketching on a plane more or less parallel to the back here. So now I can actually kind of pull useful information off of this mesh form. So I'm going to pull off the back, just project the back onto the plane that I'm working on here, and just align myself to that plane. Let's see, and add a couple of features. So I'll just add a couple of rectangles here, just to demonstrate some of the kind of cutout capabilities. So we can dimension these rectangles, or actually I'll go ahead and just again use my constraints to make all the rectangles the same size. So again, just setting the length and width of each rectangle to be identical, and we'll make these rectangles 1.25 millimeters wide. So we've added some parametric information here. We could actually even we'll go ahead and make a rect length parameter here, and we'll call that maybe 15. And we'll make that rect length. So now we have some bona fide parametric features scattered on this plane here. And now we can click Modify, and we can actually cut right through the mesh surface that we have here, or the mesh. What was a mesh surface is now a solid body, and we've made some parametric changes to it. So you can see that when we were back in the, let me just bring up that sketch really quick. You can see that when I projected that form onto that plane, you can see that it's not a very clean form. We've got some kind of some hard to describe curves here. This is a curve. This is probably what we could call a spline, but it doesn't really have any kind of control points. We just have an endpoint and a start point and an end point, and some pretty arbitrary curvature along the way, which makes it a little difficult to reference, for instance, reference the location of a feature relative to that. We can try, and it just won't let us because there's it's hard to kind of pull meaningful geometry from, or meaningful information from that. So a point is pretty stable, so I'll go ahead and select that. Set that to a distance of 4, and just I'll go ahead and make these rectangles here all, or these top lines here, all collinear. Go and stop the sketch here, and so you can see that it updated that. So it's really cool, so we can come back and we can edit this form. So we can kind of travel back to when we had the mesh in an editable state. And I'm just going to go ahead and you know, drag a face out, make this chair less comfortable. Add a big protrusion here. Go ahead, add a big protrusion there. Getting into more oddball geometry here. But the point is, we've changed the form, the space defined by that surface mesh. When we finish that form, it's going to convert back to solid, and then it's going to add all of those parametric changes that we had in our little timeline here. So what's pretty cool about this is it provides a good kind of workflow for instance, if I was trying to pull in a Cyborg Beast phalange earlier today, I've tried taking an STL and saving it as an OBJ. It seems that an OBJ can also be a triangular mesh, so the conversion process doesn't work if you the conversion process in Fusion doesn't work if you start with an STL, convert that to an OBJ in whatever kind of mesh editing software you'd like, and then import that converted OBJ. It still has triangular mesh features, and so it won't convert. But if we were to say export geometry from Blender to an OBJ, we can then pull it into Fusion and start adding some parametric points and reference those to features, projected features from the mesh. So it could provide a good kind of toolkit for editing mesh bodies with kind of more discrete parametric tools. But again, working with mesh data is messy because it's dimensionless. It's typically kind of assigned an arbitrary scale, and it's hard to get things like nice, clean right angles, straight lines, things like that. It's designed to be more of a kind of sculptural, expressive tool. But we can apply some good parametric, crisp detail to it with this tool set and with this workflow. So with that, are there any questions on the working with OBJs, converting them to an analytic T-spline surface, and then applying parametric features to them?
I have a question.
Go for it.
I have a dumb question, but you know.
No such thing.
What is a spline?
So a couple of things. I'll go ahead and just whip up a sketch real quick. So in 2D, a spline is a way of describing curve information. You can see me plotting it out here. I'll just go ahead and bring it up from the top, in which a line is described by a number of points and kind of tangencies and magnitudes of tangencies at those points. So I can control this line by controlling the kind of strength of tangency at a point. So you can see I'm just by adjusting this length, this line length here on this control segment, I'm increasing the kind of gravitation towards that line, increasing the magnitude of the attractive force, the strength of that tangency, and then as I make it shorter, decreasing the strength of that tangency. And by moving that point, I can control where the line falls. So in 2D, this is what a spline is. In 3D, T-splines describe this kind of flavor of geometry, where we have a let's see. There is a very precise definition that I don't know off the top of my head. T-splines, I believe it represents it describes this kind of quad surface that you can use for analytical surface modeling. There is a more precise, kind of mathematically grounded definition of what that is, and I can't recall that at the moment. It's definitely within kind of Google's reach, though. Rhino and several other kind of popular surface modeling tools use T-spline editing as well. So I'm sorry I can't provide a super detailed answer, but T-splines basically describes this kind of quad mesh editing technique.
So does T-spline stand for something?
I believe the T stands for it's possible to delete an edge, and so not every vertex has to be the end point of 4 edges. So I believe the T, I've been told that the T stands for what's represented by these, or the capability, which is apparently unique to T-spline services, of a service to be defined by regions having 4 edges, but vertices having either 3 or 4 intersecting edges, is what I've heard.
I see the T.
See the T. Good. So I believe that's the T in T-splines.
Okay.
Anyway, so any other questions?
Yeah, we're clear on Q&A right now.
All right. Well, again, feel free to, for those watching after the fact, feel free to hit me up on Google+, send me a Hangout message. If you'd like to join the Enable Sandbox, again, let me just toggle over, show you guys. Again, actually, this layout is all changing in just a few short days, but this is where all of the files from today live, as well as various additional geometries, so some things that Frankie's been working on, some other things I've been working on. Here's something from Steve Wood. He prototyped a flexi knee here. So we've got a lot of kind of experimental stuff hanging out here, and a lot of different people working in the sandbox. So feel free to just shoot me a message on Google Plus with the email that you used for signing up for your Autodesk account. Again, we've got a quick tutorial on our resources page on enablingthefuture.org with a quick startup guide. Takes about 5 minutes to download Fusion, get an account set up, and get your free 1-year license. So shoot me an email, and I can get you plugged into this sandbox. And again, I'll be sharing the demo files from today so that everybody can kind of poke around and work with the parameters, get a feel for kind of how these files are structured. All right. Well, I think we can call it a day, unless there are any last-minute questions.
No, we're all clear. Thank you very much for another great session.
All right. Well, great.
Yes.
Thanks, Jeremy and Lydia, for setting this up, and Jeremy for moderating questions.
Sure.
Yes, and thank you very much for taking the time to teach us these things.
Totally. Anytime.
All right.
All right. Take care, guys.